Today we're going to talk about acid and base nomenclature. Acids are named based off their anion. All acids have hydrogen, which is high, as their cation. If an anion is an element from PT, then the prefix it will usually be hydro towards the beginning, and then the suffix will be IC, which you put the element and then IC towards the end. And the acid goes at the end. So if you have hydroacid, then acid goes towards the end. Example 1 is HCl. It'll be hydro because it's an acid, and then chloric because it's chloride, but we changed the so it'll end with ic because the suffix is IC. And then acid goes at the end because acid goes after the suffix. So if an anion is a polyatomic ion, then the suffix is completely changed. So if it ends with ATE, 8, it changes to IC. And then if it's ITE, ite, then it goes to OUS. So if we have HClO3, it will change to hydrogen chloride, which will change to chloric because we have to change the suffix since it is a polyatomic ion, and then we will put acid towards the end. So we have HClO, and then they have subscripts of 2. Well, we will change that to chlorous acid because the ITE of chloride will turn to OUS, like it mentions here. The bases that contain hydroxide, which is OH- as an anion, plus follows the normal ionic nomenclature rules. Example number 3, we have NaOH. So it'll be sodium hydroxide. We put hydro in because it has an anion as a base, and then we will follow with the IDE, which is the ionic. Here we have the strong acids. It's HCl, HBr, HI, HCl03, and then HClO4. And then we have HNO3. And then we have H2SO4. And then we have the strong bases. So group 1A are metal hydroxides. And then we have LiONaOH. Then we have KOH. Then RBOH, C5OH. Then we have the heavy group, which is the 2A metal hydroxides. Lastly, we have the CaLOH with the 2 subscript. Then we have SrOH with a subscript of 2. Lastly, we have BaOH with a subscript of 2. Acid-base nomenclature.